All right, we have an amazing talk lined up today. I'm so excited to introduce Titus Barik, a researcher at Microsoft Research. I got to meet him half a decade ago, back when we were both Microsoft Research interns. And then in the interim, we co-organized Plateau one year, which for those of you who don't know, is a workshop that tackles all things PL and HCI. Titus's work bridges human-computer interaction and software engineering, and he's done some amazing work on how programming tools can make people more creative and on how to make program analysis tools more useful.
Yeah, Sarah and I had to actually like arm wrestle to figure out who was going to get to introduce Titus because we all wanted to. So
it was a fight.
Yeah.
But I won. He has an incredible knack for figuring out inventive, creative ways to learn what users need. And so with that, Titus, we're so glad to have you here. Please take it away.
Okay, so first, am I muted? I'm not muted, so that's good. Let me share my screen. Yep. Let's see, let me move this out of the way. I just got to do some prep real quick. Chat box, I will open that up. Nope, I've actually forgotten how to open the chat from here.
I just chatted with you. Did that pop something up?
Yep.
Good.
Okay, so now I've got the chat window. Great. So I'm going to load some slides. And you should be able to see some slides on your screen.
That looks good.
All right. I don't have screens. There's no place to put all this stuff. I'm like doing window management right now. Okay, so here we go. All right, so let's go ahead and get started. So let me do one more quick thing. If I move this video window, do you see it, or is Zoom smart and it hides it?
We didn't see it.
Cool, so I can make eye contact, virtually with people without it covering the screen. Great. All right, so awesome. Let's get started. Someone's mowing the lawn, which is also fantastic right now in the background. So I'm Titus. I've been at Microsoft now for about 3 years. I work in the pros team, and originally the pros team was actually just a PL team. It was, they focused on an area of PL called program synthesis, which I'll talk about briefly in a bit. And it was through some early successes that they had with thinking about not just PL, but also how to surface this PL as user interfaces to customers, that today the pros team is very multidisciplinary. It's exactly the summer school, having people that are both PL and HCI and various parts of the spectrum. So I'm more HCI. There are some people who are more PL, and there are others who are sort of in the middle somewhere, part PL, part HCI. And so in this talk, I'm gonna, share some of the experiences I've had of working in this team and doing research within the pros team, and also how some of my views on how to conduct research have, changed from how I thought about things when I was a grad student and working in industry. So I know several of the organizers mentioned things to think about, like violating expectations and things that were surprising to you. So I'm going to put my own sort of background processing on this as you listen to the talk and decide, what you should focus on. So there are sort of 3 background processes you should have in your head, I hope, as I go through this talk. The first is, really think about this blending of PL and HCI and how we've tried to do this in the pros team. So instead of thinking of, PL as being this one flower and HCI maybe being this other flower as gears, that thinking of ourselves as, multidisciplinary toolsmiths. Our goal is to try to build really interesting things, and it doesn't really matter where it comes from. It can come from and be inspired by anywhere. The second thing I'd like you to think about, and some of you are already in the PhD program, some of you are getting an advisor, thinking about going into the PhD, is you've seen one talk yesterday from Amy. You're going to see many more talks throughout the week, and think about the different lenses of how to conduct user research. There isn't really one way to do it. There are lots of different research paradigms for how people think about research. And as I've been at Microsoft, I've worked pretty closely with product teams, and I found that some of the ways they were doing research, even though they didn't call it research the way we call it research, I found them to be really useful, some of the techniques. So I started incorporating them into my own academic research. And so just kind of think about that, go through the course of the week, you know, all the different lenses of how people are doing research, and that there may be many right ways to do it. The third one is kind of sort of this philosophical lens that I always thought about when I was a grad student. And this was, you know, it's phrased in different ways. It's not good enough syndrome or imposter syndrome, things like that. Decision paralysis, all of these show in. And what I'd like you to get out of this talk is, you know, even yesterday I attended the talk and people were saying things like, you know, maybe there's one more thing to do. How do I know if I'm ready to show people my study? Shouldn't I, you know, fix this one thing or the other thing? So I'm going to show you, you know, different stages of user research that we did within Microsoft to try to get you to, you know, think that research is a continuous process. You know, avoid this decision paralysis monster. You know, when we publish papers, it looks like it's a straight line, right? This thing that happened, but it's actually a very messy process. And probably all the experiments you're doing, you know, go ahead and do them with users, with customers. It's probably good enough, and I'll show you some things we've actually done at Microsoft to help you with that. Okay, so this is a school of PL and HCI, and as you know, Microsoft is probably one of the largest software engineering companies. We have, you know, C#, TypeScript, .NET, and so it makes sense to start this talk with what I think is the world's most popular development environment. And of course, that's Microsoft Excel, which you probably expected. So you may be wondering, why is Microsoft Excel a programming environment? And what, you know, where in this space does PL fit in? So I'm going to start the talk with something, you know, the pros team developed over a decade ago. It was this feature called Flash Fill. So let me pop out of the talk real quick and show you Flash Fill. And this may be the only demo in the talk that actually works because it shipped, you know, over a decade ago. The rest I'm not so sure about. So the idea behind Flash Fill, if you haven't used it, is that we wanted to enable people who weren't necessarily programmers to be able to do automation within this spreadsheet format. There are a variety of common, you know, data transformation sort of activities that they did, but people weren't able to do them because they weren't programmers. So imagine here that I have something like Titus Barik, my name, and you want to do some abbreviation for presentation. So I maybe want T Barik to appear. So maybe there's a lot of PL people here. If you want, you know, type in the chat real quick. How would you write a program to do this? You can just paste some pseudocode of what you think would be a nice algorithm for taking A and B and turning it into this string. So I'm going to wait, you know, oh, could you make the font bigger? Now it's bigger. Is that better? Is that, okay, perfect. So now the person who asked the question, Daniel, is obligated to give an answer since I answered your question. What do you think a pseudocode might be for how to do this task?
Well, unfortunately I know about Flash Fill, but
yeah, whatever language, you know, you would.
I guess like some string language,
sure.
or like it tries to find similarities between the columns.
Oh, so this is actually, so it's a good idea, but this is actually going to be much simpler than that. Maybe we could just make a program that takes the first letter of the string, the first string, appends a period to it, concatenates with a space, and then just concatenates the last name. So it's a bunch of concats and substrings that would do this. Well, even this is too hard for people who aren't programmers. And so the Flash Fill feature, you can go under Data Tools and hit Flash Fill, does exactly that for you. Behind the scenes, it generates a program that does this task. You know, this set of concatenations and substrings, etc. Okay, so we've all seen this before, or at least many of us have. Something interesting happened on Twitter recently. So somebody wanted to do this task. So these are some months, you know, here, DEC, NOV, OCT, and I see people pasting some formulas. Yep, that's exactly right. So let's see what'll happen now. So what they really want to do is take a short month and make it, you know, the full month. All right, so let's run flash fill again. Hey, December, November. Welcome to Augember, everybody. You know, that's great. So what do we think is happening here? So I'm not a programmer, I typed this in, you know, this is kind of a very amusing thing, but some of us are, you know, PL researchers or think from a PL perspective. So what do we think happened with the algorithm now? And I'll let you just put in a quick chat. Why is it doing this? Yeah, so again, it's just like the names. So this version of FlashFill, this program synthesis algorithm, it doesn't really know about types other than strings. So it doesn't know about date times, it doesn't know about numbers or Booleans. So it doesn't know that these are months of the year, it just sees them as a string. And this is why we get, you know, Augember or Aprember, and I would argue this is actually correct. This is the way months should be named. It's much more logical than the way we name them today. So let's go back to the slides. So given that, I want to think about two ways we could improve this sort of experience for the user. Move this window. So you can imagine that there are some knobs that we could use to fix this problem, and they might be PL, they might be human-computer interaction, or they might be both of these things. So on the PL side, one way to fix this would be, you know, why don't we add support for other data types? We should be able to detect that something is a number, a Boolean, or an entity like a date time, and not do string programs for it, but instead do date time programs. So perhaps the PL is fixed and we're only HCI researchers. Another way we might fix this problem from the HCI perspective or try to address it is maybe we could show the end user the formula. Right? If we showed them the formula, yes, it's still embarrassing that the months don't complete, but they could see what the underlying logic is, and perhaps they could understand, okay, it makes sense why the computer is trying to solve it this way, even though I think it's, you know, kind of a ridiculous way to do it. Or you could combine both of them. We could both fix date time and add data types, and we can do the HCI approach by exposing the formula. Okay, so this was almost a decade ago or over a decade ago, and I wanted to show you this feature to get us to start thinking about both PL and HCI and the different ways we can try to improve a user experience for a product. All right, so a lot of time passes, and I joined the company in 2017. Okay, yeah. So time passes, I joined the company in 2017, and we end up in a part of the org called Azure. You know, our primary funding becomes Azure. They become interested in the pros team because, you know, they saw the Excel work we did and they said, you know, that end user stuff you were doing looks like data wrangling, looks like data transformations. That might be useful to data scientists, and I wonder if there's a way to help them. So what I'm going to do next is I'm going to look at two extremes of data science. You know, I'm going to look at this thing called REPLs, read, evaluate, you know, print, loop, just to sort of bootstrap some of the discussion, and then I'm going to flip that over to notebooks. I know there's many different ways data scientists do work, but I'm just going to contrast the two together, and that will help us, you know, motivate why we're building some of the tools and did some of the research we did. Okay. So now you should see a terminal on the screen. Let me know if the font size is good for this. Okay. And I've got the Python prompt here. So this is what we call the REPL experience. You zoom 7 times. I don't know how many times I zoom now. All right. So in a REPL, I can type 2 + 2. That's great, and I'm doing Python, which is a popular language for data scientists. I can do like 0.1 + 0.2, if I can type. Close enough, probably pretty good. Machine learning, won't worry about that. I can print stuff like hello, Titus. And so far, this was me just directing to a programming environment, an interpreter, and sending commands to it. And the environment in the background is storing some state. So this is great, but what data scientists usually want to do is they want to start, plotting. And this is where the REPL form factor sort of breaks down. It's good because I can just, very quickly type things and try things out. But it becomes a little more tedious when I have to do more complicated work. So I'm going to load matplotlib. Maybe I'm going to load some libraries, write some code, steal some code from Stack Overflow that does plotting, pasted that in. And what this does is it shows a chart. So as simple as it gets, here's my sine wave. So this is an approximation of tasks data scientists might do. So this chart is great. I'd like to do some more analysis on this. So I go back to the REPL, and of course I can't type anything because it turns out in this REPL, the UI thread is blocking it. So what can I do? I can either save this file, or let me close it out, but then I lose the chart. Oh, and there's all my text that I was typing. So I can scroll up and maybe I type PLT show again and nothing happens. Uh-oh. And the reason nothing happened is this is a side effecting command where once you plot it, it shows it on the screen and erases it. And if I want to plot it again, you can go through history and I would have to set up all these commands again, probably get it wrong. And let's see what I get now. Nope, I messed it up, right? So I don't have a plot. So because of these sort of limitations, data scientists desired a better way to do work that could support this sort of REPL style experience. The benefits that they liked of having a REPL and being able to quickly type commands and try things out with compiling, but also that address some of the challenges of the user experience in the REPL, which is having to retype a lot of the commands, figuring out how to group them and what to run to rerun an experiment and do an analysis. So because of that, notebooks started to become very popular in the community. So let me try to make this font a little bigger too. And what I'd like you to think about here is that the notebook is in some ways a lot like a REPL. It's almost a GUI that's superimposed over the same REPL experience. And if you look at the code for it, you'll see, on the back end, you'll see that the REPL is still there. There's message queues and little things, but at its core, it's fundamentally sending strings, eval commands to the REPL. But by making some changes to the HCI, to the user interface, that same REPL experience becomes much more powerful. So the very first thing you can see is that before we were typing in lines at a time. And now we're able to group them. These are called cells. So instead of being line-oriented, we can be cell-oriented. So I've organized all my imports in one location. I've done my logic, the thing I want to plot here, and I have my plot logic as a third cell. And I can, of course, independently run these or run these all at once. A nice thing is the plot just appears. I don't have to render it. I can, very quickly explore. So I wonder what, cosine looks like. And now I only have to run these two cells, and that's what cosine looks like. Maybe I actually wanted to try two different plots. So let me just go down here and compare sine and cosine. So that's sine. Let's do a cosine here. And if you're a software engineer, you might be panicking at how much I'm just copy and pasting to get stuff to happen. But this is how data scientists work, right? They just, ad hoc code, do some exploratory analysis. Uh-oh. So let's see, sine. Is that right? Yeah, so they are actually, 90 degrees off phase. So cool. So maybe as an IDE user, if you're a software engineer, that was very scary. But that's how data scientists work. We load some data, try some things out, experiment, keep some results, throw away some other results. And whether it's something like Azure Machine Learning, or we can load this in Jupyter Lab, assuming my cloud instance works. Waiting for cache. Okay, and all of the notebooks have this sort of similar structure. Cells, you can execute things in any order and display on the screen. The thing I want you to take away from that discussion or that talk that I just did on the REPLs is the underlying technology is actually the same. It's all based on that REPL. So the PL is still this interpreter behind the scenes that people are sending commands to. What has made it really useful to data scientists is this ability to wrap it or reframe it in a very different user experience while keeping the underlying PL the same. And just by doing that, it's made it a much more powerful and useful experience for data scientists. Okay, so the thing now is, where does research fit in here? So all of these notebooks have all of these features, but these are kind of table stakes. Like every notebook you ship should have these things. So this is where the researchers fit in. Our goal as a researcher, at least I see it in industry, or the reason, industry, when they collaborate with academics, do so, is we want to be able to provide, these differentiated experiences for all of these platforms. We want to be able to provide features in notebooks that don't exist in other notebooks that are out there. We want people to be able to say things like, I've never seen something like that before. That was super cool. And I think that's really great for researchers, right? Because that's kind of what we're already asked to do as a research, as being in a research team or being a researcher. We want to develop some novel interaction or some sort of novel technology. But if you frame it that way, if you frame it as, I've built a novel interaction paradigm, it doesn't really resonate with product teams. But if you phrase it instead as, this is a differentiated experience that will provide value for your customers, just reframing it in that second way, even though you're doing the same thing, makes it much easier for me as a researcher to work with product teams. So let's look at some of these differentiated experiences. So I'm going to talk about two tools that we've built. One is called Rex for data wrangling. And you noticed when I was doing this exploratory data science, my notebook got like really messy. Some of those, maybe I don't want the cosine thing that I did. So the second tool is managing messes. And near the end of the talk, we'll discuss, how do we find more problems? So there were two problems here, but what's a systematic way to find things to build and do that? So in this work for Rex, it was led by Ian Drosos. He was an intern with me who did the Rex project. Andrew Head, many of you know in the HCI community, was also an intern with myself and Rob DeLine to do that project. The first author of the third paper, she goes by Rini, and she did a lot of this work to do this need finding, to find opportunities for things we could build further. So before we had any of these projects, the first problem we usually have is participants. We need to find participants to talk to. So typically in any research project, the first thing I do, even before I have a precise research project or a precise research question, is I try to find a participant pool of people I'm likely to need in the future. Fortunately at Microsoft, this is pretty easy, and I haven't figured out how to replicate this in academia. So large companies have this sort of company address book, and I just do a query in the address book. So here I want data scientists, and I'll be able to find all of the data scientists. Of course, this doesn't really help because there are many types of data scientists. Some work in R, some work in notebooks, so on and so forth. So regardless of the study, usually the second thing I'll do is I'll take that set of data scientists and I'll send out a recruitment survey. So this is not a random sample. The goal of this is a purposive sampling. We're trying to find people for a particular study. and I'll send out a very short survey. It's usually, 2 to 3 questions. It'll say, how often do you use notebooks? If I'm doing a notebook study, that would be important to filter this bigger set of data scientists. What languages do you use? If our prototypes and our demos are in Python, maybe, Scala programmers aren't right for this audience. And I found it useful to ask in every one of these surveys when I'm trying to do recruitment, this question of what is something you find frustrating? And what this helps me with is an idea called theoretical saturation. So imagine I'm talking to a lot of participants and they're talking about this problem of out of order execution. They say, notebooks get really complicated because you can execute things out of order and it confuses me. And so I talk to 2 or 3 people and I keep hearing the same thing over and over. Out of order execution, out of order execution. And maybe I've learned all I can about that. What else is frustrating? And by having this sort of question, I can then, look for a more diverse set of people who have different challenges. I could find someone who says, oh, plotting is really hard. And then I can say, oh, that's interesting. Let me follow up with them. So that's the typical process I use for first, finding participants in the company directory, and then doing this sort of quick survey to refine the analysis. So we sometimes call these screeners. Yeah, and so some people in the chat mentioned that, this is also a very broad thing. It's true. So an even broader title is software engineer, which means many things. So you almost have to do this second order survey or sampling to find, a more fine-grained audience to help you with your tool. Okay, so I'm going to talk about one more thing because it came up yesterday in the talk. So that's one type of participant where we look in the company directory directly. There's another type of way that we can communicate with customers, and that's through telemetry. So unfortunately, there are a lot of misconceptions, especially in academia, about how we use telemetry. So this is a system called 1ES, and there's the HeadTracks database that I showed you earlier, which has the, the employees of the company, but there's also our DDTel VS Code, which I have access to, which gives me things like raw events from VS Code. So this uses a language called Custo, and I don't get, participants. Let me just, for PII, let me try to run this query on a separate window just to make sure what shows up. Yeah, that looks fine. So all I've done is I've looked at the raw events table and I've just limited it to 5. And what this gives us is typically there's an event name that tells us, someone's doing something, something happened, and we add this, these hooks. These are things we want to capture in the telemetry. And there's usually some metadata or measures that we record about that particular event. I'm not going to expand that because I'm not really sure what's in there, but there's some metadata in that. And we don't know who they are exactly, but there's usually some sort of session ID or machine ID, which we use to approximately track them, and learn information about them. Whoops. So which of these is more useful? It turns out that actually the first, being able to just use the company directory to get participants, is the real superpower. In academia, there's often the sense that this sort of big data and getting a lot of events is useful. In HCI research, I found it to be not particularly useful. And the reason is the type of metrics we collect are typically just counters. They help, business processes and help us make business decisions about how often people are using things. They can also help us with bug reports. If there's an anomaly or an exception, we can sort of filter down in this set to try to figure out, what conditions are causing this bug. Unfortunately, we don't, other than counts, we don't really see much in the telemetry, and we're not able to collect anything else. So people think, in academia that, we have this gold mine of data, but the telemetry has not really been that much useful for me other than, the two things I mentioned, customer usage and identifying bugs in products. It's actually being able to connect with customers in that easy way through head tracks that has been the real, superpower in this, in my HCI research. Okay. All right, so now we found those participants. At Microsoft, we call them quick pulses. In HCI literature, we call them formative interviews. And so what we do in the formative interviews is, I think of these as like just lightweight coffee chats, n equals very small. And the goal of these is, even before building the product, just to get some signals about, what it is that makes sense to build. And then just having this initial, North Star talking to users that there's actually a problem to address before we even build any tools, often before we build any mockups. And these translate into our paper, at least in HCI, as either design goals or design motivations. These are the reasons why we decided to build this tool or product. And I won't read them here. We'll talk about them in detail when we get to the study. So from one of these formative interviews, we decided to build this tool called Rex, which is to help data scientists who are working in notebooks do data wrangling. But I'm going to do a quick detour before that. So remember that flash fill thing in Excel I showed you? We actually shipped this one more time. It made it into a product called AML Workbench. And it made it into public preview, which is another way of saying beta. And AML Workbench was this product to do end-to-end machine learning through this desktop GUI application. And one small component of that, codename Pendleton, was data preparation. So it was supposed to help people in this pipeline do data preparation. And the reason I showed you Excel, even though it was a decade old, was to show you this Pendleton project as sort of the next iteration of that. Unfortunately, so 3 problems I will mention. Pendleton never shipped. It never shipped to GA. After beta, they decided to discontinue the product. Not because of the data prep part, but there were other factors at play. So that was kind of a shame. The second thing I'll mention is that we added support for a bunch of the PL things that users complained about in Excel. The third problem is there's no accessibility in this product because it was a beta, and so I can't actually make the font bigger. So I'm really sorry about that, but maybe I'll explain, the user experience here. So just like flash fill, you can right-click. I'm just going to tell you what I'm doing since it's even small for me. I'm going to select this option called Derive Column by Example, which is basically flash fill. And let's say I just want the word traffic. So these are traffic : vehicle accident, fire : fire alarms. That's the format of this data. And if I just want traffic, I can just type the word traffic. And sure enough, it completes, very flash fill style. I can maybe, decide I want to uppercase it and give an example. And everything got capitalized and it did a substring. Right, so it took the first, traffic, fire, etc. Okay. So what about the other scenarios we had talked about? Remember October? So here's a kind of messy string. And someone mentioned on Zoom that you can actually zoom in yourself through the feature. So you see a string, it's got like Cedar Avenue and Cottage Avenue something, and there's a date sandwiched in here somewhere in between. So we can do derive column again. And this is kind of a mixed string. It's got strings and dates in it, but maybe I just want the month. So I'll type in December. And all of these are December, but you can see that there's some Januaries in here, and it extracts the month. Let's do a couple more examples. So that was dates. I wonder if there's another date I can do. Let's see if I can do day of the week. So I'm going to do a drive column again, just like flash fill. Let's do Friday. And so I think 2015-12-11 is a Friday, so it's completed the day of the week. So on the PL side, we improved flash fill. So it no longer is strings. It can do things data scientists kind of wanted to do. These are dates and times, times transformations, which data scientists work with often. So we can also do numbers. We added support for, so I can pick 2 columns. Oh, that was Twitter, not someone texting me. And let's say I want to round. So I'll do 40.17 minus 75.12. I want to build coordinates out of this set. And I can hit enter, and the system has figured out that I want to do some rounding. Oh, that's actually not correct. Oops. Because it's 40.18. I typed it wrong. So we do that one again. 40.18 minus 75. Yeah, if you put garbage in, you get garbage out. But if I do something reasonable, I get something reasonable back. So I've taken 2 numbers and concatenated them together and rounded them. And I can do this for other data types like Boolean. So we addressed a lot of the limitations of the original flash fill and sort of supercharged it, flash fill plus plus. Just scrolling through the chat real quick. Yeah, so this is one of the key ideas of program synthesis. One of the forms of program synthesis is using examples, input and output example pairs, and then through a domain-specific language that knows a variety of different operators, generating a program to do that transformation, and using various fun things like constraint solvers and stuff. Program synthesis is often able to do this sort of operation very, very quickly. Just for the heck of it, I don't know. I really like date times. I wonder if this works. So this one might break. I've never tried it. So let's try 1 p.m. I'm curious. AM PM is always. Yeah, so it's able to extract date times in this format: 1 p.m., 8 a.m., etc. All right. So that was the data prep tool at Microsoft. Let me go back to the slides. So here's the problem. Super useful thing, flash fill plus plus, we didn't ship the product. So customers didn't get it directly. And so we wanted to learn more about why. And so we conducted that formative interview process that I told you about earlier. And we found sort of 2 design principles or 2 design motivations for why people didn't really like this product. So one of the things we repeatedly heard when doing these formative interviews, the tool was useful to people who are maybe GUI programmers, but a lot of the data scientists who we were targeting, they did know how to code. They didn't code like software engineers, but they liked to program. And so the first design motivation they told us is that, yeah, this technology is really, really cool, but I don't want to have to leave where I'm working to be able to use it. I'm not going to switch to this other product just to be able to do the data wrangling part. Notebooks are super useful for me for all sorts of things, plotting, exploration, and I'm not going to leave my super cool tool in notebooks just to use your other tool. So that was D1, and that was one of our goals, is to try to address this problem. There was actually a second problem we found that we didn't really notice in the Pendleton data prep release, is that data scientists were really uncomfortable with the black magic, the little dark arts that was happening behind the scene. Many of you in the chat said, it's magic, right? Excel users were perfectly fine with this, but data scientists said, I'm not comfortable just looking at, these rows randomly and you telling me there's a program and I'm now supposed to run this over terabytes of data without seeing it. So that gave us a second design goal, which is that data wrangling tools need to be inspectable and modifiable. And they even gave us a further guidance. They said, I don't want to learn a specialized language. I already know Python or R. You need to be able to generate this inspection in Python and R. Okay, so how do we go about doing this? let's do some quick mockups. So we made some low fidelity mockups, and this is where we go back to that it's probably good enough, right? This is what we started showing customers. We drew it just like this. This is the exact, wireframe that we gave them. I hope you like my art. So we made a little browser, Jupyter notebook. It says Jupyter. Here's the grid, you saw in Pendleton, except we put it inside the notebook. So when you print a data frame, you get this grid. And we walk them through this experience. So step 1, you type some code, you preview a notebook. Step 2, you will right-click on it and hit Derive. So on and so forth. Step 3, you'll click on one of those new columns and type in an example. I've lost count of what step I'm on, a problem in computer science. Step 4, I'm going to type in something like San Diego, right? And we showed this to customers and they seem to like it. So what do we do next? Well, we typically, so that's basically our first study. So if you're thinking you need to build a big, ambitious tool or system, you don't. You can do pencil and paper prototyping. It's very common. And even at Microsoft, that's what we do. We talk to participants and show them these low fidelity mockups or wireframes. As we get slightly past that and want to actually build something out, we switch this to what we call high fidelity mockups or a design system. So I'm going to show you that next, and we'll see why that's important. So for that, I use a tool called Figma. It's sort of a company standard. So first I'll start with this idea of a design system. So a design system is a set of rules. It's a set of almost a language for user interface things that are allowable in your system. So it specifies things like the colors that you're supposed to use, or the icons and fonts and buttons and how things should look within it. This is for VS Code. It's the design system we use at Microsoft. And you can see things like icons, how buttons are supposed to look, drop downs. Somewhere in here, in this big long list, is a little template. So there's the VS Code editor. Okay, so I didn't make a complete design system because I'm a researcher. I don't need this full system yet. But as we're building out the product for the Kai paper, we did make a high fidelity version of our design. So still, we haven't actually written a single line of code. We're just showing various increments of this idea to customers in different ways. And this is a little bit, more polished. It looks like Chrome. It's got the user experience and what things will look like. We took their feedback that they wanted Python programs. We generated Python programs, so on and so forth, right? So that was round 2. Okay, so what's next? We did low fidelity mockups, couple days. Sometimes we can do those in a single day. High fidelity mockups, same thing, run a study, do it in a single day, get customer feedback or participant feedback. And then spend maybe 1 or 2 weeks building what we call a POC or a proof of concept. So this is, however you can hack together an end-to-end experience that's actually interactive that people can run. It can crash, it can break. It may not even look precisely like the high fidelity mockup, but it's something that users can just sort of, interactively type things and try things out for themselves. So let me show you that next. All right, so I'm gonna try to make the font bigger. It's probably gonna break. So here's what we built. This is what we ran the Kai user study on in our paper. We took not even Jupyter Lab, not Azure Notebooks, but Jupyter Classic, one of the early versions of Jupyter, and patched it in to support this interactive experience. So I'm going to run this cell. Then I'm going to run this second cell. And what did this actually do? Apparently reading this file is, so this is a non-interactive grid. So we added this command called show grid. The grid didn't even show on its own. We had to actually explicitly call show grid on some columns. And when we do that, there's our interactive grid that we showed to our participants. And if you remember the Pendleton demo, it's the same exact file I used in the Pendleton demo with fewer columns. So again, I can do derive selected column, and I can type in something like EMS. And it will either crash or complete. Okay, completed. There's some synthesized code here. And you'll notice for the study, the code is actually not the split code. It did something a little convoluted. It's correct, but weird. You know, it's looking for things between colons instead of just splitting on the colon. But we can see that it works. People can actually interact with this. I want to capitalize something, so I get dot upper. And now, you know, this box looks nothing like the high fidelity version of the box that we have here, but it works for purposes of the user study. So they type use this code, and I get a function. I can call the function as a unit test, and the program seems to work. It can take a string and give us back EMS, and we can do some useful data science. All right, cool. This is what we ran against our customers, you know, our participants. I'm just looking through the chat real quick. All right. So that was the POC. We conducted, you're going to get different feedback on how to run studies. So in this particular paper, we ran a very cookie cutter study. I call it cookie cutter because you see this template over and over in HCI research. It goes like this. You have some tasks, and you have the three typical measures. Effectiveness, which is, you know, how quickly, you know, they were able to solve the task against some baseline. You have efficiency. Oh, I think I mixed these up. Right, I mixed up the labels. So this is correctness or effectiveness, efficiency, and user satisfaction. Did they like the tool that they're seeing? And the reason I say this is cookie cutter is because the measures on the right typically fall out from the study. They do whatever they'll do. You'll get p-values or you won't get p-values. The times will do the things they'll do. It's the part that seems to be the most important for doing research is actually the task selection. It's the task selection that determines whether the activity is reasonable, whether it's something that data scientists would actually do, whether it generalizes, you know, it covers a range of activities that they would do. And because of this, you know, as you're doing user research, I would encourage you to actually, you know, I do this as well, focus most of your effort on the task design. You know, what are the things you want the participants to do? And the rest of the metrics all sort of fall out from these. I talked a bit about the HCI side. I also want to talk a bit about the PL side, you know, what was going on here on the PL. So there's actually a pretty complicated paper. It was submitted to CAV about this. This is the Chi version of what is happening. So I simplified it down to something pretty informal. We called it the readable code synthesis algorithm. And it basically has three phases. So phase one, you put in some examples. So I gave two examples before, EMS and fire, I think. And you pass it to the original, you know, flash fill program. And the reason you do this is that flash fill was really optimized for taking in very few examples. You could give it only one or two examples, and it would be able to generate a program for you. The trade-off for being able to, you know, give one or two examples was that it generated really gnarly programs. It tried to overcompensate for things it hadn't seen in the examples or the data to try to be sort of robust to those. So generated really gnarly programs. Fine for something like Excel where users don't want to see the program. Not so good for data scientists where they want to see the program. So how do we get the best of both? Well, we do one or two examples. We pass them into what we call the flash fill ranker. That was the Excel black box ranker. Then we take whatever program it gave back and we apply that program to all of the examples in the data frame, or a large number of examples in the data frame. This bootstraps or solves the problem of few examples. You know, we've synthetically created many, many examples by running this ugly program on top of all the examples. But, you know, it worked. And then what we do is we take those many examples and pass it into a different synthesis engine. It has what's called a readability ranker. And the readability ranker is really good at generating readable programs. But the downside is, of course, it needs many examples. And so we pipeline the two synthesizers, P1 and P2, to do that. Then there's the third phase. What the third phase does is you can almost think of it as like an optimizer phase in a compiler. Through user feedback, we just found people had preferences for things. And so we sort of, did this almost peephole optimization where we just kind of patched up the readable program a little bit more to clean it up. All of these are done in an internal language. It's a domain-specific language. It's not Python or R. It's sort of an intermediate representation for being able to compute and do program synthesis. So to get this to code, we translate it to the target, taking in this program, and then, for good measure, we run it through a code formatter, like PEP8 or, Black or one of these code formatters, and we show it to the user. So I said, I think we submitted this to CAV. It did not get into CAV, but we'll talk about one of the phases of this. So it was called P3 rewrite, that little optimizer, and it looks something like this. Given a signature F of something or another, E = sign. This is how I read PL papers, by the way. I just sort of skim it like this. And it has this thing called local cube PBE, which I think means local quantitative programming by example or something like that. As you can see, I'm more on the HCI end. So when I submitted this, wanted to submit this to Kai, I got a description like this, and I said, hard pass. We can't present, even though this is a good, formal definition, there's no way we can present it in this way to an HCI audience. So we rewrote it. No pun intended. So we rewrote it for a Kai audience. And instead of presenting it as this formalism, the way I wrote it in the paper was that the goal of this phase in rewriting, we're just looking at P3, is to take one program and make it a program that's a bit simpler to understand. And in words, instead of in kind of a proof format, I just explain what's happening. We're going to do these rewrite rules that we did, and we're going to change the semantics of the program a little bit. This is kind of a trick. So the original flash fill would generate programs like this to overcompensate for inputs it hadn't seen. So if you're matching numbers, why not look for commas and things like that just in case? But if the data the user doesn't see didn't have those, this is a bewildering program to show them. So instead, we will rewrite it to just, here's some digits. And that's the program we would show them. And we were very direct about this. We explained it, replacing the first regex by the second, these don't match the same things. But from the user's perspective, if they never knew about this first program and only saw the second, behaviorally, from their perspective, they're the same programs. Now, here's why I pointed this out. So, when we made this argument to a formal methods conference like CAV, and, we said, is that cool that we did that? We actually broke the program. We had a better program and gave you a worse program, but the users liked it more. They said, no, that was not cool. Kai was very, Kai thought very differently about this in the HCI field. And one of the reviewers wrote, they especially enjoyed this section, particularly phase 3. Trading off this, insight of semantic equivalence in favor of behavioral equivalence. And behavioral equivalence is, again, that thing where what the user sees from their perspective looks the same. And the key insight here was it's when the user can interactively provide additional examples. So we did provide them with a slightly worse program in some sense, but it was more readable. And because the user was in the loop, if they wanted that more complicated program, they could just provide examples. They could provide a number with commas in it. And that sort of short circuits this problem. And I think this is kind of like the cool thing of being multidisciplinary. And I really, maybe one of the reviewers are actually in the audience, but they wrote that this is the hallmark of work that combines PL and HCI. So I think PL and HCI here, this is a great example of how things work better together by each taking the strengths and weaknesses to try to complement each other to do something, that works for users, making trade-offs. So put another way, my academic advisor, Tyrion Lannister from University of Game of Thrones said, once you've accepted your flaws, no one can use them against you. And that's how I sort of think about publishing. If we know what our limitations are of our tools, and we know what the trade-offs are. Instead of thinking of them as weaknesses that we need to hide, by combining sort of HCI thinking with PL thinking, we can instead think about how, maybe those weaknesses are actually strengths, or maybe how we can use user interfaces or present the information in a certain way to where the weaknesses don't matter as much for our users. Okay, so let's look at a second tool real quick. So this is the gather tool. We did the same process as before. You have until, okay, let's wrap up 10 minutes. Cool. Okay, so it's somewhat similar to the Rex study. Same process, we found 3 guidelines there that they gave us. One was, manage the messes. I made a messy notebook. I want portable code. This one was a little weird. It didn't really resonate. Portable code here means copy paste. Do I want to copy paste? Do I want to generate a script? Most people just wanted another notebook. And the third one, I really don't even understand myself. So clearly the users didn't either. It's querying the code via direct analysis of some sort. Okay, so again, we built the POC, and the POC is already there. So you'll notice I made this. We added this feature at once that you could select any of the cells. And you can see these purple lines that have lit up here showing which lines of code are related to this plot, and you can gather to a notebook. And instead of this messy notebook that had lots of cells, this only takes the lines of code that are related to the program. We actually ship this in VS Code. So I can click these buttons, run the program. This third cell is not relevant. And I only want this plot, and it's surfaced in a different way as a toolbar button. And if you hit gather, it will eventually work or crash. And you can see here the same thing. So this is the version that is actually shipped. You can go download this now and use it in Visual Studio. All right, so I need to start wrapping up. So here we reused a thing you've already seen from Amy called program slicing. So the really cool thing I think about PL and HCI collaboration is PL is almost a toolbox for me of different formalisms that you can use. And we use the same slicing algorithm that Amy used in her talk for Y-line, but we surfaced it in a very different way. Instead of helping with debugging, we reframed it as a way to help data scientists clean up their notebooks. So there's the paper. The slicing didn't quite work though. So when we had to go to product, we had to do a bunch of engineering because Python is kind of a messy language. And our workaround was to create this thing called specs. And this is a fancy way of saying we just hard-coded a bunch of stuff. We looked through a bunch of libraries and just hard-coded all the things that were side effecting to make this a bit more robust. The end result of this paper, there was a lot of data, but the only thing the product team really cared about was, did people like it? Was it useful? And they found this gather feature to be really useful, and they mostly ignored everything else. All right, I'm not gonna have time to do the last study, which is a survey study, because I got too excited about the tools. So I'm gonna move on to lessons learned and finish the talk. So tips for technology building. So the first thing that's resonated with me working at Microsoft is we need to find a way to make our ideas accessible to others. Papers are really useful for researchers, but if we can show them as demos or blog posts, those get much more readers and much more visitors than any of the papers I've ever written. And part of that is because we reframe our ideas. Instead of calling something as a unified programming by example framework, we say, here's a tool that will improve the lives of data scientists. You saw that none of the things showed up exactly where we thought they would. So part of technology building is having a paper, but being flexible about where stuff shows up. Whether it's in VS Code or the IDE or something else. And the last one is to deliver things in bite-sized pieces. So building these big ambitious systems, it's very hard to ship. See if you can carve out, smaller pieces of the product that you can ship in various different products. My last slide is on lessons learned, things I knew, wish I knew as a PhD student. So for some reason as a PhD student, I got it in my head that science and engineering were two different things. And if you were building systems, that's engineering, not science. These days, I sort of think of them as both. Both are informing the research process, both are also informing the engineering process, and they just work in different cadences. I've stopped thinking about publishing in terms of papers, but in terms of focusing on problems that are meaningful to users. So I start with what's something that could be useful to our users. And as a result of doing that, I found that, the papers follow. It's hard to have faith in that, but it really does seem like if you focus on users and what they want, the papers will follow. The third thing, that I took away is, as a PhD student, I was always worried about solving the problems that I'm solving being too simple. Like all I did was clean up a notebook. All I did was, show a small snippet of code in a grid. And for this, the advice I think I would give is, don't worry about solving problems that seem too simple. There's this thing of a complexity monster and it will sort of emerge on its own. You won't have to go finding complexity. It's the simple problems that seem deceptively simple because they're simple to explain. They're not necessarily simple to solve. And I think those are actually the most interesting problems. So the next time you land on a simple problem, or you think it's too simple of a problem, maybe reconsider and try to solve it anyway. It might be an interesting research contribution. All right, thanks. That's the end of my talk.
Thank you, Titus. Tour de force. All right. Let us all break up maybe 5 minutes max. Yes, okay. I'm already seeing some raised hands. So Avril, why don't you start?
Yeah. So my question is, what happens when Rex goes wrong? So we saw examples where it was able to discern the pattern from the inputs, but if I write in some garbage, it can give me some garbage, but maybe the first few rows look correct. And if it's terabytes of data, I can't check all the rows. So how does it handle those cases?
Yeah, so this is a great example of why having a continuous engagement with a product team could be useful, because it's not just a one-shot effort. There are many subsequent research problems that you didn't see in the demo to try to address this. So we saw this as well in our user studies and in the tool, and a feature we came up with was called distinguishing inputs. And it's not shown in the interface, but the system makes recommendations about columns that it thinks like it looks a little bit different than the inputs you've given it so far. And it will suggest edge cases to look at. Like if you're doing numbers, it'll say, well, there's this one with a comma in it. Why don't you visually inspect this to see if it makes sense to you? We haven't yet solved the problem of generating just completely messy programs because it has this garbage in, garbage out problem. What we have found, though, is our data scientists do know Python. And so when they see these garbage programs, they can infer that either, I just have to do it manually and they'll drop to doing it manually themselves, or they'll recognize that something has gone wrong or they've specified something incorrectly. What we found that was interesting is often it was somewhere in the middle. It was 80% right sometimes. Like it mostly did their task, but not all of it. And our data scientists were really, perfectly happy with this. It saved them some time. And just by making some small tweaks, they were able to get to 100% instead of having synthesis need to be perfectly correct the first time.
Okay.
Excellent.
Yeah, thanks.
Next, Kasra, please ask your question.
Oh, hi. Thank you for the fantastic talk, by the way. But we had one specific question about when you were going through the process, you mentioned these two different levels of doing mockups, where you do a low fidelity one and then go to a high fidelity one. We were wondering specifically because oftentimes time is a huge constraint. What is specifically the benefit of doing the high fidelity mockup? Because a lot of times, at least from my own experience, what I've seen is we go from low fidelity to a proof of concept. So what are you specifically looking for there?
Yeah, so the this is the thing. This is one of the things I stole from product teams, is doing the high fidelity mockups. When I was in university, I did low fidelity POC paper, and the reason for this is you get two very different types of feedback from the participant. So in the low fidelity mockup, it's more about ideas and how they interact with the system and high level goals. What the high fidelity helps you with, if you actually want to, put the system in a product, it gives you a lot of the low level details. Like, wait, you weren't able to see the button. Wait, you thought you were going to right click. Why did you think you wanted to right click versus this? Or why did you click on the drop down? Or why are you moving the cursor over there, right? So it gives you two different levels of resolution of feedback. The high fidelity gives you, moment by moment feedback, which is important for actually getting people to use it. And the low fidelity gives you this more design goals style of feedback, which is why I do both.
Wonderful. Felipe, why don't you go ahead?
Oh, hi. Well, thanks for the talk. It was really great. We had a question about the Pendleton project.
Sure.
It seemed that there was a lot of effort there that didn't actually make it into the final product. So if you could elaborate on how do you deal with this, like research dead ends, or like whether there's waste, and how do you move forward from a project that has like this abrupt end?
Yeah, that was kind of sad. They even gave me this badge. Like, we shipped it, right? You can put it on a shirt or something that 9/25/27, and then a month later you killed the whole thing. Okay, so the way I'll phrase this: Microsoft is still learning. There are different orgs that operate in different ways. And one of the things that I think we're doing better now, which is why HCI is so important right now in Microsoft, there's so much demand for it, is that we had this mindset before that we were smart people and we could build a product sitting in a room, and if we just marketed it well enough, people would use it. And this, like you said, this was a very long multi-year effort, and we learned that that is not the right way to build products. And there are parts of the org that still build it this way. But DevDiv, which is the Visual Studio, Visual Studio Code team, has adopted a new mindset, which is why I think, people like me fit really well now within the PL community, is that we need to have this continuous learning process where we're always getting feedback as we build the product. We're actually talking to users and seeing what they do rather than, making assumptions about these products. And that's what we learned from it. The second thing is, you talked about, the product failed. Well, not really. The technology is all still there. And so we can resurface a lot of this technology in different ways. The Azure Notebooks thing never showed up yet, with the Gather the Messy Notebooks tool. That was our original goal. But it did show up in VS Code, which is kind of neat, and it did get shipped. So that's just being flexible about where things show up, and the technology can be reused, and you can always reiterate and try again.
Wonderful. Michael Koblenz, why don't you go ahead?
Thanks. Yeah, thanks for the talk. One thing our group was talking about is the comment from your reviewer about this sort of trade-off between semantics and simplicity, or usability being a fundamental aspect of PL+HCI work. And I'm wondering what your thoughts are on that. To what extent do you agree? I've encountered a lot of different kinds of trade-offs, and I'm wondering what your thoughts are.
Yeah, so I think there's sort of a middle ground or a sweet spot. So the risk I always see, at least from the PL side, is I really appreciate this sort of sense of formalism and doing things in a sound way that you can make certain guarantees about. The downside to this is, the trade-off is it takes much longer sometimes to get into the hands of customers. Where if you were willing to say, I'll make some reasonable compromises, yeah, the algorithm is not fully, correct. Think about TypeScript, right? The type system is actually not a sound type system. It's pretty broken in a number of ways, but it's still useful. It's like still super useful to developers. So the formalism is important, but sometimes users can get value out of a system or a tool, even if that hasn't, fully materialized. And we see this time and time again with Gather. Program slicing doesn't really work in Python. You need a strong type system to get typing to work. But if you do these sort of workarounds in real life cases, it works for most people most of the time. And I think, you know, as sort of a practitioner industry researcher now, that's where I see the interesting space of how can we develop tools that work for most people most of the time? Because if you try to get that long tail to 100%, that's where I see a big bottleneck, and, you know, sometimes this research never making it to people.
Thank you.
Awesome. Great question. Justin Lubin, go ahead.
Hi, yeah, thank you for the talk. It was really great. So we were talking about in my group, given that PL and HCI can often be very forward-looking, how do you balance solving concrete problems that exist now versus creating entirely new paradigms or systems that present like a new approach or mindset to tackling these problems?
Yeah, so especially completely novel systems are very hard to get in. So many companies say, you know, they're innovative and want to be innovative, but at the end of the day, products are pretty conservative. So this is why, you know, many of the novel user interfaces for coding, like code bubbles and these sort of non-file based interfaces, have never made it into products. So the way I think about this is the way I think about like a stock portfolio or an investment portfolio, right? So you should have a set of almost like conservative projects that are a bit smaller in scope, but have a much clearer pathway to getting out to a person if you want to actually ship the product. And that core sort of conservative set of investments help you fund sort of the longer term things. At Microsoft, we've actually formalized this. We call them horizons. So we call it like H1, H2, H3. H1 is sort of near term prototype tool building, maybe 6 months to a year sort of projects. H2 is 1 year to 2 year time spans. So this lets you have a little bit more creativity about, you know, maybe in 2 years, user interfaces will look like this. And then we have H3, which is 2 years to maybe 5 years or even farther out. And this is the more exploratory research. And I think the key is, you know, to actually do all of these, they kind of inform each other, but have a nice balance between this, you know, H1, H2, H3, and that's what I found works successfully in an industrial setting.
Thank you.
Rahul, go ahead and ask your question.
Hey Titus, really loved your talk. What I found really interesting is your approach towards the recruitment, that you send a very short survey first, like 2 to 5 questions, that gives you a taste of like, you know, what are the problems. Would you compare and contrast in places where you don't have this luxury of follow-on, the methods that you can, or the tricks that we can use on the survey itself, like, you know, long form surveys or short form surveys or something of that sort? Just give us more pointers on that.
Yeah, so this is really a large company superpower. It's not the telemetry, it's just having access to this participant pool. When I was a student or in grad school, this was a huge bottleneck. You know, even getting 12 people could take me 2 or 3 weeks or even a month to try to do. And now, you know, in a day, I can, you know, Microsoft has 40,000 software engineers or something. It's very easy to find participants. And even in the slide, I had a little monster icon because I haven't really figured out how to do this in an academic setting. And what I have found that has worked, it's a bit of an escape hatch, is people yesterday talked about, you know, how do I work with large companies on building tools? And I think the actual right question is, how do I work with a large company to do research and share participants? Because a lot of the times what happens is there are all these kind of cool theoretical or empirical studies that none of us really have time to handle. But we do have a lot of participants available to us. And I think this is where the collaboration can actually happen. So the Pain Points paper was with Oregon State. And the reason that worked is because we didn't really have the energy to be able to study pain points systematically across many different notebooks. So we collaborated. The other way to do this, so I don't really have advice for short versus long. We found that short tends to work better, and the response rate externally is very low. Internally, it's quite high. It can be as high as, like, you know, 40, 50%, sometimes 80%. And so unfortunately, I don't have really good advice there. Yeah, I don't have great advice there for you as to what to do. But as a short term, I would suggest, collaborating with, companies on the study part, not necessarily the tool part, could be one way, to do this.
Surveys are hard, man, but this was really cool in terms of like sending a pre-survey to gather participants. I really like that idea. Thank you.
All right, we have 2 more questions, and we're give ourselves till 12:03 to get through them, and then we'll let the social chairs take over. So Will and Tyler. Will, go ahead first.
Yeah, I wanted to follow up on Justin's question about research time horizons. So if you're thinking about H3 type projects, I'm curious how you would change your research methodology. Would you ask different survey questions, or what other methods do you use to generate ideas about the far future as opposed to immediate problems faced by developers today?
Yeah, so the way I would actually think about that differently is now when I do H1, H2, I always have a target product in mind. So even if it's not in the paper, I think, this would probably be good for VS Code, or maybe this is something for Microsoft Office. And the difference, I think, with H3 is I decouple that constraint. I say, it doesn't really matter what products are currently available in the market space. I'm willing to build something myself, even from scratch, totally different. Maybe a new way of thinking about, the world or the problem space. So I don't really change my methodology very much. I just change my perspective on how closely aligned to a particular product I want to be. But otherwise, I think the process for me is still very similar. I would still make these mock-ups and try them with customers. I would still build prototypes. I would still get this feedback from participants. One difference might be in terms of how I evaluate. So often with the H3 work, there's not really a good baseline. Right? It's very hard to come up with what the controlled version of the experiment would be. So one change there is the way I run the study is there is no baseline. It's more about qualitative feedback about how this would improve how data scientists or software engineers work. And you won't see those, bean counting metrics there, like, speed and performance and that sort of thing. So.
Cool, thank you.
All right, our final question goes to Tyler Holloway. Go ahead.
Hi, so we didn't get to the systematic ways to find pain points, needs, and design opportunities. So what are maybe one or a couple ways or a couple pieces of advice that you would offer about that?
I missed part of the question. Could you just repeat the question?
Yeah, sure. So what pieces of advice would you offer about pain points, needs, and design opportunities, like finding systematic ways to find all of those 3 things?
Yeah, so that was the last part of the talk I didn't get to, so I'm glad you asked the question. So in both topic 1 and topic 2, Rex and Gather, we sort of had priors to tell us, either a past product that had failed or some lightweight way of knowing. So the advice here I would give, the protocol I run for finding these opportunities is I start with a semi-structured interview. What's your day-to-day work is one of the questions, just to understand, what's special about their work. I asked about challenges that they have, these sort of questions. And then I try to do a diverse sampling. That's where the frustration question comes in. I heard a lot about people talking about plotting being hard. Are there other things that are hard? And I use that sort of initial survey to try to do the saturation process. So the problem with this is that interviews can say whatever they want. They could be making things up. They could be misrepresenting things. Maybe they think it's hard and it's not actually as hard as it is for everyone. So the very next thing I do is I take all of those challenges and I turn them into survey form. I literally will turn them into a Likert scale survey. And this way I can validate that the things that they've said are actually happening at a broader scale, just not to the 20 people I've talked to. And I find from combining the two, you get the best of both. You get very detailed feedback about why people are having problems. And you also have this sort of broad spectrum, almost ranking of why things are hard for certain people or how many people are likely to be affected by this problem. And I'm not the first person to come up with a study design, but if you're trying to find a problem in the first place, or it's an area you don't know really well, or the research community doesn't know really well, this seems to be a pretty good approach to getting some confidence about what problems to solve.
All right. Thank you, Titus.
Thank you, Titus. That was the last question. Really grateful for you coming and sharing these 3 projects with us.